Let's look at another example and do a synthesis problem given Claisen and Aldol products. So first of all, we're looking at the top one. We can see this is clearly an Aldol type product because it's got the C double bond C. So what I'll do is I will split the C double bond C apart, and I'll put the alpha hydrogens on the one that needs them, which is going to be this one. And we will put the C double bond O on the one that does not have the C double bond O, which is this one. And we'll figure out what kind it is, and it looks like it to be a standard aldol and not a Novnagle. And the way we know that is that we've got two compounds. Each one has a single C double bonded oxygen. There's none there that have two double bonded O's. So going back to the test question number 1, we'll be able to tell whether or not it's an aldol or a Novnagle by referencing that. See, the Novnagle here is going to have the two C double bond O's, and those are the conditions you'd use for a Novnagle. And the aldol, each one has just one C double bond O, and these are the conditions we'll use for a standard aldol. So that's the one we're going to choose, the standard aldol, which is NaOH and H2O. Alright, so that completes that first one. Now the second one is clearly a Claisen type product because we've got the ester grouping and the ketone grouping here. And as I discussed earlier, what we do to reverse this is to break the alpha and beta carbon bond to the ester group. So that's the alpha, that's the beta, and this is the bond we would break here. And what I know is that the portion that has the ester grouping will get the hydrogen, and the portion that has the C double bond O will get the ester grouping. So I'll go ahead and do that. Now this is an isopropyl group here. It doesn't really matter what it is. You'll just have to make sure that everything matches that particular ester grouping. I'll show you that in a second. So as I said, this is going to get the O with the IPR part. Alright, so this has to match, the OIPR has to match this ester grouping as well. And then I can put my standard Claisen conditions in here, so it'll be Na, but again the base I use must match the ester that I have. So that would be NaOIPR, and this would be IPR OH for the solvent. So all of these esters have to match, and the base has to use the same ester grouping to avoid the transesterification problem, and the solvent for the base has to match the base as well. So this would be IPROH as well. So all of those have to match. And again, if you have problems or you're not sure of the conditions for a Claisen process, what you can do is you can go back to the original test question 1, and you can hunt down a standard Claisen process, which would be this one here, which has the two esters reacting with the base in the appropriate alcohol, and you can see that you can just use that as a guide to figuring out the conditions required for your particular process. And since this is a Claisen, you would use the same kinds of conditions, and that's what we've done up here as well.